Welcome to this video on engineering mathematics, focusing on Unit 1, Algebra and Polynomials.
A polynomial is a mathematical expression with variables and constants joined by operators, where exponents must be non-negative integers. We can see here the difference between a valid polynomial and one that is not. This slide breaks down the components of a polynomial. Variables are the unknowns, coefficients are the numbers multiplying them, and the degree is the highest power in the expression. Polynomials are classified by their degree. A degree of 1 is linear, 2 is quadratic, 3 is cubic, and 4 is quartic. Each has a distinct graphical representation. Next, we will look at how to master polynomial operations, including addition, subtraction, and multiplication. Remember the two golden rules. First, you can only combine like terms with the exact same letter and power. Second, use the distributive property and remember the index law, where powers are added when multiplying. For polynomial addition, simply group and combine your like terms. Start by underlining similar terms, then add their coefficients. Consider this example. Open bracket, 3x squared plus 2x plus 5, close bracket, plus, open bracket, 2x squared plus 4x plus 1, close bracket. Before adding anything, group all the like terms together. The x squared terms become 3x squared plus 2x squared. The x terms become 2x plus 4x. Finally, the constants become 5 plus 1. Now perform the addition. 3x squared plus 2x squared equals 5x squared. 2x plus 4x equals 6x. 5 plus 1 equals 6. Therefore, the final answer is 5x squared plus 6x plus 6. Always remember, identify like terms first, then add their coefficients. Here is an addition challenge. By pairing the terms by their power, we can simplify the expression step by step to reach the final answer. Subtraction comes with a sign change trap. You must change the sign for every term inside the second bracket before you begin solving. Now let's move on to subtraction of polynomials. This is where many students lose marks because of one common mistake. Before combining like terms, you must distribute the negative sign to every term inside the second bracket. Let's look at this example. Open bracket, 7x squared plus 8x minus 3, close bracket, minus, open bracket, 3x squared plus 2x plus 4, close bracket. First, remove the bracket by changing the sign of every term inside it. Positive 3x squared becomes negative 3x squared. Positive 2x becomes negative 2x. Positive 4 becomes negative 4. Now combine the like terms. 7x squared minus 3x squared equals 4x squared. 8x minus 2x equals 6x. Negative 3 minus 4 equals negative 7. Therefore, the final answer is 4x squared plus 6x minus 7. Always remember, subtracting a bracket means changing every sign inside the bracket. To multiply polynomials, we use the distributive property, also known as the rainbow method. At the same time, remember the law of indices. When multiplying variables with the same base, we add their exponents. Let's solve this example. 3x multiplied by the bracket 2x squared minus 5x plus 4. The first step is to multiply 3x with every term inside the bracket. First, 3x multiplied by 2x squared. Multiply the coefficients. 3 times 2 equals 6. Then multiply the variables. X to the power of 1 multiplied by x squared becomes x cubed. So the first term is 6x cubed. Next, 3x multiplied by negative 5x. 3 times negative 5 equals negative 15. X multiplied by x becomes x squared. So the second term is negative 15x squared. Finally, 3x multiplied by 4. 3 times 4 equals 12. Then attach the x, so we get 12x. Therefore, the final answer is 6x cubed minus 15x squared plus 12x. The rainbow method ensures that every term inside the bracket is multiplied correctly. Never skip a term, or your final answer will be incomplete.
When expanding double brackets, split the expression to distribute each part systematically. This ensures you cover all terms in the final multiplication.
This quick review summarizes our rules. Combine like terms for addition and subtraction, and use rainbow distribution for multiplication, always watching for common pitfalls. Now, it is time to move. Work in groups to rotate through stations, solving addition, subtraction, and multiplication puzzles. To summarize, we effectively combine like terms by grouping them by their power: cubed terms, squared terms, variable terms, and constants. This slide demonstrates the distribution method for multiplying polynomials. By systematically multiplying each term in the first bracket by each term in the second, we arrive at the full product, which is then simplified by combining like terms. In summary, remember these essentials. Polynomials are like modular blocks. Keep track of the variable, coefficient, and degree. When performing operations, remember to group by degree for addition and subtraction. Distribute every term for multiplication, and use the divide, multiply, subtract cycle for division.